In this video we discuss about the evidence of water and organic compound on Mars. The Curiosity rover has provided compelling evidence of past water on Mars, supporting the long-standing hypothesis that the planet was once a much wetter and more hospitable place. Here are some of the key discoveries made by Curiosity that indicate the presence of ancient water. Ancient streambeds. One of the earliest pieces of evidence came shortly after Curiosity's landing in Gale crater. The rover observed and photographed rounded pebbles and gravel within the crater, which are strong indicators of past flowing water. These rounded pebbles are typically formed by the action of water over time, rounding and smoothing the edges of rocks as they roll and collide in a stream or riverbed. Lakebed deposits. As Curiosity explored the lower slopes of Mount Sharp, it encountered sedimentary rock formations that are indicative of an ancient lakebed. These sedimentary rocks, including mudstones and sandstones, provided evidence that a large lake once existed in the Gale crater. The presence of a lake indicates that liquid water must have been present for an extended period in Mars' past. Chemical analysis. Curiosity's instruments, such as the chemistry and mineralogy, SCHMANN, and sample analysis at Mars, SAM, instruments, have been used to analyze rock and soil samples. These analyses have revealed the presence of minerals that typically form in the presence of water, further supporting the idea of past water activity on Mars. Gypsum deposits. Curiosity detected gypsum deposits in the sedimentary rocks on Mount Sharp. Gypsum is a mineral that often forms in the presence of water, particularly in evaporating water bodies like lakes or ancient seas. The discovery of gypsum suggests that liquid water played a role in the geological history of the region. Recurring slope lineae, RSL. Although not directly observed by Curiosity, other spacecraft orbiting Mars have detected features known as recurring slope lineae, RSL. These dark streaks appear on steep slopes during warmer seasons and fade away during colder seasons. Scientists believe that RSL may be evidence of briny water flowing temporarily on the surface. Clay minerals. Curiosity has discovered clay minerals in the rocks of Mount Sharp. Clay minerals generally form in the presence of liquid water over extended periods, indicating that the region once had a more water-rich environment. These findings collectively indicate that Mars had a much wetter and more habitable past billions of years ago. The evidence of past water is a crucial discovery in the search for potential past life on Mars and helps scientists better understand the planet's geological and climatic history. While liquid water is not stable on the Martian surface today due to the thin atmosphere and low temperatures, the study of ancient water features contributes to our understanding of the planet's potential for hosting life in its distant past. Rippled rock textures. In 2022, Curiosity found rippled rock textures in the foothills of Mount Sharp, which are the clearest evidence yet of ancient water ripples that formed within lakes. These ripples were created by waves on the surface of a shallow lake, which stirred up sediment at the lake bottom. Over time, the sediment formed into rocks with rippled textures. Image of rippled rock textures found by Curiosity rover minerals that form in water. Curiosity has also found minerals that can only form in the presence of water, such as jarosite and carbonates. These minerals were found in rocks that were once part of an ancient lakebed. Image of minerals that form in water found by Curiosity rover chemical signatures of water. Curiosity has also found chemical signatures of water in the Martian soil. These chemical signatures indicate that water once flowed on the surface of Mars, and that it may still be present in the subsurface. Image of chemical signatures of water found by Curiosity rover. These are just a few of the many pieces of evidence that have been found by the Curiosity rover that suggest that Mars once had a much wetter climate than it does today. This evidence is helping scientists to better understand the history of water on Mars, and to search for signs of life that may have once existed on the planet.